we are going to talk about namespaces in the next 75 minutes just before lunch. So before I get into the details about the agenda like that, let me quickly introduce myself. My name is Sandor DARGO. I worked for Spotify for the last couple of years. In my free time, I enjoy writing. I write a lot about C++, but not only about C++. It's a fun fact that I started to learn and write about wine as well, mostly French wine for a Hungarian magazine. But the next article will be about, surprisingly, an English wine, some ginger wine that I received a few months ago from my wife. And by the way, special thanks to her that she's taking care of all the family while I'm being here with you. So, why about namespaces? Why do I talk about namespaces today? Well, they are a great tool for cleaner code organization. It's important to learn about them. And I think that especially in the beginning, many developers miss out on the benefits of using namespaces well, in fact, because I think all developers we do use namespaces, at least the standard namespace. And I want to share some practical tips that I think it would have been good for me in the beginning, but some of them I just learned later on. So a little bit about the agenda. There will be 4 sections, but the first 2 will be quite short. First, there will be an intro to namespaces, about what they are, why we should use them, and then we'll see the evolution of namespaces over the last almost 30 years, or it depends how you count it, even more than 30 years. Then we'll have 2 longer sections, one about namespace mechanics and scope rules, and probably the longest one is about best practices for using namespaces in various different ways. Is that fine for you? Yeah, feel free to interrupt at any moment with questions if you have, or with remarks. So let's start with the introduction to namespaces. First question is, what are namespaces? What's a namespace? How would you define it? Yes?
It kind of encapsulates code within to a namespace. So you have to call a certain namespace in order to access certain classes or methods, functions. Is that right?
Yeah, it's right. You can group different symbols all together under a specified name, and we can also call it under a specified scope. So basically, we can introduce new scopes with namespaces. Many would call them logical scopes, and well, to cover the technicalities, you declare a new namespace with the keyword namespace, and then comes a name. And they can be nested. So you can have various layers of namespaces. And once you close one, it doesn't mean that you cannot extend it later. You can open up a namespace anytime, and you can add more symbols, later on as you wish. And the way you access a namespace is through the colon, the namespace resolution operator. That's interesting. Something I missed in the beginning while I started to learn about C++ and I started to use C++ is the proper naming of things, like different operators. For example, recently I heard someone saying, and I'm interested if you recognize what I'm talking about, the less than operator. Or bit shift or? Yes. And this is something I clearly missed in the beginning. That's why I found it important to even to write it out a scope resolution operator for the colon. So why do we want to use namespaces? For one thing, we want to use namespaces for better code organization because it lets us organizing code into logical units, and in many cases they look like code folders, and often people actually use them in parallel with code folders. So on in your repository, you will create folders for different services, different parts, different modules of your code base, and often you will see you will use the same folder names for namespaces. Not necessarily, but that's often how it's done. Well, it improves the modularity of your code. It also improves readability. If namespaces are used well, we'll see some of the best practices. The main reason to use namespaces still is reducing the risk of redefinition errors and naming conflicts and other mysterious bugs. Some we'll see explore together, and it helps us scaling projects better. They become more manageable. In fact, using namespaces is essential for larger code bases, for code bases that use external code, which are, well, quite a few code bases use that, and to avoid clashes. But this is quite vague so far, I think. So let's go with some more precise examples. So we want to avoid name collisions between different libraries. We want to keep large projects APIs manageable, and we want to create clear boundaries between modules. And now let's jump over to namespace evolution. Do you know when do you think that namespaces were part of the original C++ language created in the 80s? I see people nodding. I see people saying no. No, they were not part of it. Namespaces were introduced in the 90s. So officially, they became part of the language with the C++98 standard. But I think it was proposed, well, I found different data, but somewhere around 93, 95. And it was quickly adopted to the standard, but the standard itself was accepted a bit later. That's why it's called C++98, but the different compilers implemented namespaces quite quickly. But they had most of the key features from the start, and you will see that not so many things were added over the last 20-something years, which is not bad. So they already provided name collision prevention, their main reason. Of course, you could create logical groupings for your code. It gave us scope control, and already from the beginning, we had the standard namespace. The using directive and declaration. We'll see what the differences are between the using directive and declaration. So here is a bit of example code. You will see most of it already. So we start by creating a namespace called lib. Maybe I shouldn't use the highlighting. There we define a variable within the namespace lib, and we have a function in it called print value, which prints the value as this variable. The way to use it in our main function is to use the scope resolution operator with the namespace and the function name, so we call lib print value. But then we can use a using directive. We'll cover that deeper later to introduce the to introduce all the symbols of the lib namespace, something that you should barely use, if ever, but we'll talk more about that later. And then you see that we can print value directly. You can also use using declaration. You see it with using standard cout, which only introduces the cout symbol into the current scope, and then we don't have to qualify cout with std : So we already have all this since C++ 98, but it went through some evolution. So C++ 11 gave us inline namespaces. Is there anyone here who is using inline namespaces frequently? No? Yeah. That's not a coincidence. It's not really it's not really recommended to use it a lot, but it's good for certain things. But what are inline namespaces first? So if you take an inline namespace, you'll see that it a bit acts like if it was the enclosing scope. It's treated, symbols in an inline namespace are treated as if they were part of the parent scope. So here, this example, we can see that we have namespace my library. Oh, I want to highlight that in a bit longer examples like this one, I mean longer as it comes to a slide, you will have a Godbolt link, and you will get the slides later on, and you can play with the examples. So in this my library namespace, there are two nested namespaces, v1 and v2, and both of them define a function called print message. But namespace v2 is inline. So what does it mean? If we go to main, you see that, well, we can call my library v1 print message, and it will print, well, it will print whatever, because we didn't define that, but it calls print message in v1 namespace, obviously. v2 print message calls print message in v2, but we can also just say my library print message. It will also call v2 because namespace v2 is an inline namespace. So a symbol in such an inline namespace is handled as if it was already part of the parent namespace, in this case, my library. It makes versioning easier because you see the inline version can be directly used, and this means that if you are managing an API where you maintain different versions of the functionality, you can mark the latest, or not necessarily the latest, but the main version that you want to support as inline. And when you think it's time for others to use, time for everyone to use another version, you just make that one inline. That's something you can do. And that's basically the only thing inline namespaces are recommended for, if they are recommended for. Because even on that, people, well, not everyone agrees, I would say. And yeah, this is ideal for the latest version. So this was C++ 11. C++ 17 brought us nested namespace openings. So what does it mean? Before C++ 17, if you wanted to create nested namespaces, then you had to do something like this. You open a namespace outer, then you open another namespace called inner, and then you can, for example, forward declare a class there. This is, well, this is fine, but you know, it's a bit verbose. So since C++ 17, you can do something much nicer. You say namespace outer, : inner, and there you can declare your symbols. C++ 20 iterated on this, and it brought us nested inline namespaces, something I've never seen being used, but you can, well, you can open nested inline namespaces much easier. So instead of this, you get this, which, to be fair, to me, seems a bit strange because you have that space between inline and the namespace inner. Of course, it needs to be there, but it just makes it a bit strange. But you can do this as well since C++ 20. So let's move on and let's talk about namespace mechanics and scope rules. So first we are going to talk about name lookup rules. We'll see how name lookups can happen. We are going to talk about qualified, unqualified name lookups and ADL as well, argument-dependent lookups. So what is qualified name lookup? Well, when you see something like this, A, colon, B, colon, X, that's there X is a qualified name. And for that, a qualified name lookup will happen. We'll see in details that there's a bit more to that. Maybe I lie a little bit here, but we'll see. So the lookup starts with what's on the left of the scope resolution operator. On the left of X, we have AB. And the search is confined to the specified scope. I'll give you many examples for this. And unlike for unqualified name lookup, it will not jump to an outer scope or to any other scope automatically. We'll see how using directives are considered when we get to the examples. So here's the first one for qualified name lookup. Here we have this piece of code. So what happens here? In main, we want to print A, B, X. So we ask for this. And first, the lookup happens in A, B. So we see that we have this nested namespace A, B. And there, X is found. In fact, X is found in two different ways, because we declared X right there with the value 2. But there is also using namespace C, which introduces X, but it has a less priority. So what is getting printed is 2. In some cases, though, if we didn't have that X declared there with value 2, that's the difference here, that we still ask for ABX, but now we have that line commented out, that's the only difference, then the compiler will still find X, because we had this line using namespace C. And as you can see there, oh, pun not intended, namespace C also declares a variable X with a value of 3. So in this case, that's found, and we print 3 as a result. I have a third example when nothing is getting printed, because as I mentioned, for qualified name lookups, we won't end up in any other scope, in outer scopes automatically. And in this case, we still have our AB nested namespace, but and we are using, we are asking for the value of W, but we have no W declared within namespace B. We have a W, though, in namespace A, just one level upper. but it's not considered. So what happens here is a compilation error because ABW is not found with this qualified name lookup. Now let's move to unqualified name lookups. In this case, you're looking for symbols not appearing on the right-hand side of the scope resolution operator. So in this example, we have x equals 2 outside of the function. But in the function, we also have x with the value 3. So here you can see the difference between unqualified and qualified name lookups. So first we say int y equals x. And there x is not qualified. There is no scope resolution operator there. So it will find the local version of x, 3. You see that when we declare z, we use colon colon x, and here colon colon without anything on the left-hand side means that we are looking for the global namespace. Well, here it's not a full piece of code that you can just compile. But imagine we have no namespace created, declared anywhere. So it goes to a global namespace. It's qualified like that, and it will find the version. It will find the version of x with value 2. So here are a couple of rules, priorities for unqualified name lookup, and in the order of importance. So the lookup can go outward to find a declaration from a local scope. For local scopes, from the innermost to external scopes. So in this case, you see that after declaring y, we open a scope, and we want to assign the value of x to y, but x is not found within this scope, so it goes one out, and it finds it on a function level. So very good, it finds value 3 for x. It can go higher up in the hierarchy. It can go to a class or struct level scope. So in this case, in our member function func, when we want to use the value x, and that's not declared locally in func, first we go to a struct level, class level, and we find the member variable x, which is 3. So we are fine with that. Unqualified name lookup succeeds. It can go on a namespace level from, again, innermost to extern scopes. So here in namespace A, B, in function f, we want to return n. So you remember that in the qualified version, when we were looking for ABW, and W was declared in A, we didn't find anything, because with qualified name lookup, we don't just jump to an external scope. Here we do. N is not found in F. N is not found in B either, but then N is found in namespace A, and we return that. It can go even higher. It can reach the global scope. So let's say we have our namespaces, but it doesn't find n anywhere, but it finds n. It finds n outside of any user-declared namespace in the global scope. Well, it still succeeds. Well, with the same priority, the global scope, it will consider variables, symbols introduced via using directives as well. It's a bit longer example here. So if you look at the main, at the bottom of the slide, you see that we are looking for ABG and we are printing ABG and ABH. We're calling these functions. And in G, we have using directive, using namespace C. So we introduce all the symbols of the C namespace and we return Z. And in namespace C, we indeed have a Z, so we print 7. For H, we return X. Let's omit for the time being what's commented out there. And do we have X? Yes. Yes, we have X in the global namespace, which is 2, so we print 2. But we have there a commented line using namespace C. And in C, up there, we also have X, defined as 8. So if we uncomment this line, for example, we'll no more compile, because there will be an ambiguity between the global X and the X defined in C. They are considered with, say, with the same priority, and the compiler finds more of them, 2 of them, so it cannot decide what to print. So it says, okay, it cannot be compiled. If, well, this was a using directive. There is also using declaration that we saw that it introduces only one specific symbol from a given namespace. It has the same priority as local scopes. We'll have an example for that later on. So here I say that qualified and unqualified name lookups often go hand in hand. And that's why I said in the beginning when we started to talk about qualified name lookups that with A, B, X, I lied a bit. So if I want to be more precise, it's not A, B, X, it's A, colon, colon, B, colon, colon, X. So why does it matter that I said all the scope resolution operators? It's because I didn't start with the scope resolution operator. Meaning that there is a difference if you look at foo, the foo function. There's a difference between colon, colon, B, colon, colon, X and B, colon, colon, X. They would return different results. So actually, if you look at BX, it triggers both qualified and unqualified name lookups because, B, if you consider this whole expression, B is unqualified. So we have to do an unqualified lookup for namespace B there. Then we do a qualifying lookup for X within Bx. And that's why the difference in return values here, because from int foo, when we try to find X, we go outer and outer levels, right? So we are looking for B, and we will not find the namespace B, where namespace B is opened within the global namespace. But we will find a namespace B that is declared nested within namespace A, because we don't start from external until we find a symbol, but we start from the local scope and we try to find here B. Am I clear with that? Okay. So with that, we jump to the third type of lookups, which is argument-dependent lookup. It's sort of an extension of unqualified name lookup, and it only works for function calls. So it doesn't work with class names, for example. We'll see, and it makes functions just work. It brings into scope the function argument namespaces. Now this might sound a bit ugly. We'll see an example for this just in a moment. So why is this useful? Why do we want to learn about argument-dependent lookup? Why do we need it? Because it's helpful for operator overloading or generic code. But how? So here's an example. Let me check on the time. Here we have a namespace math, where we have two structs, vector and the bar. The bar takes a vector. We have two functions here. We have the normalize functions taking a vector, and we have equals equals operator taking two vectors. It doesn't matter what they do. So then we close the math namespace, and we have a function called foo, where we declare a and b from with the type math vector, and then we call normalize. Normalize is within the namespace math, yet we don't qualify normalize with this namespace. We don't call it math colon colon normalize, and then we pass the vector. You don't have to, because the namespaces of function arguments are now within scope, thanks to argument-dependent lookup. So function parameter is math vec, so math is in the scope. Again, it's very useful for example, for this operator equal equal. We can compare A with B without having to do any ugly code there. Here it's even more useful than with the normalize function, right? But you cannot just declare, a variable with the class bar, expecting that you can declare it without the namespace qualification. You have to fully qualify it, because it doesn't apply for class names. Yes. So what if we have a normalize function in the global scope, which takes an integer. So if I'm right, then still the same normalized function will be called, because even though you have, but the compiler will find it as well, but if you take A and B, they are math vecs. They are not integers, so you cannot call the normalized function with an integer. You cannot call this normalized function in math with an integer, so it will still find this one. The question is if without argument-dependent lookup, we wouldn't be able to use, for example, the equals equals operator. We couldn't do any comparison. Yes and no. I think you could still do that, but not as nicely. You would have to qualify it. So it would look like, how would it look like? Instead of writing A equals equals B, you would have to write something like math colon colon operator equals equals, and then within parentheses, you would pass A and B. Yeah. So it works, but it's not really readable, right? So the same, what if we have normalize in the global scope with a vector? It's a good question. I think it's well defined what happens and which one has precedence, but we'd have to try that. I would have to try that. So, still talking about namespace mechanics, how we can bring symbols from different namespaces into scope. We said that there are using directives, which looks like this. Using namespace ns, where ns is a namespace. Something that you should barely use, or I read some articles where they wrote that you should forget that this even exists, this possibility. But okay, we here have our namespace lib with its print function, and then let's say in another file we have main, and we bring everything from lib into scope, so we can just call print. That's fine. Seems it's nothing really malicious, but even here, like, okay, you call print, and you might ask the question, maybe not here, because this is a short example. Where does this print come from? How do you know? Well, you have to find it. Okay, or maybe if you use modern IDE, then you just hover on it and you will see where it comes from, and you trust it, and it's fine. Or you ask Copilot to tell you. Well, joking, but it might decrease the readability because, well, you don't know where it comes from, and it's a double-edged sword, as we will see, because it pollutes the namespace. So, what is namespace pollution? We stop for a second to talk about pollution.
Is it that there are too long namespace names? Too much text, maybe?
Sorry, can you repeat? I didn't hear.
Is it that some namespaces may be very long and that you have to type them all over the place?
So you're saying that some namespaces are very long and you have to type them out? No, not really. It just decreases readability if you have very long namespace names, and if you have to, type them all the time.
Is it something like, because the way you included another namespace into your into the lower namespace, so you included various functions that are quite simply named for that specific namespace.
So
they become part of a bigger namespace, which can confuse people. Like
yes. I think it's more about that. Yeah. So you take namespaces from one scope and you include it in your local scope, in your local namespace, whatever, we'll see. And then you just start having too many symbols in the same namespace. And it increases also the possibility for name clashes there. And even worse, in some cases, maybe something else will happen than you would expect. And maybe, especially in a bit code base, you won't even realize until there is a bug and you don't understand why this bug is, and then you have to debug, and well, you will find it eventually. So the pollution is when you have just too many identifiers, too many symbols in a namespace, and it can cause conflicts and confusion. I think that confusion is worse than conflict, but maybe I'm alone with that. So here are a couple of examples for namespace pollution. So let's say that you have this helper header here. We do something bad. We say using namespace std. So we introduce everything from the standard namespace into scope. Then we open up namespace foo, and there, we define a function, or we create a function called display, and it uses cout without the std qualification, because, thanks to using namespace std, we can do so. Then, in our main CPP, we include this helper header, and we write our own function called cout. Again, probably this is a terrible idea, because cout is so well known that you should not use this name. But, well, who hasn't seen bad code? So there we want to print something within cout, and then we are in main, and we call foo display. That's fine, it works. But then we want to use or cout that we just defined right up there. But instead, we get an error because, oh, cout doesn't work like that. As it turns out, there is a conflict there because we included a header which already introduced everything from the std namespace into the current scope, meaning that, well, we didn't write in main CPP anything like using namespace std, but it was written in one of the headers that we included. And that's why it pollutes, our scope here. And, well, we have an error. But that's just one example. I brought you another one, which I borrowed from Jason Turner. I think I added this like last night. I was watching one of your videos about namespace pollution, and I really like this example. So let's imagine that you have a namespace where you have a function called calculate. It takes a double, it returns a double. It does some math on it. And then you include this header in main CPP. You say, well, let's use all the symbols from this namespace 1, and you print the result of the calculation. See that you call calculate with 2. What do you expect to have? There's no trick here. There's no trick here. It will be 8.4, yeah. And then, okay, we still have this one. But then we create another file where we open another header called, another namespace called namespace2, and there is another calculate function. It takes an int, returns an int. And yeah, here in these slides, you see very limited amount of code. But you can imagine that there are many more functions in these namespaces. They just wouldn't fit here. And of course, the main would be much bigger as well. And now maybe for another calculation, we want to use something else from namespace 2. We wrote somewhere using namespace ns2. What will happen now? What's the output now? 84? Yes. It's 84. Why?
Small integer argument.
Yes, it will take the one with, it will take calculate function from ns2 because that one takes an integer. And before ns1 calculate worked because, well, there were some implicit conversions there ongoing. But now there's a better option in the overload resolution set, so it will take that one. And maybe, probably, in a longer example, this was not your intention. You just wanted to use something else from ns2. But as a side effect, existing code started to behave differently. That's why I said that namespace pollution can lead to conflicts. We saw an example for that, or to confusion. This is the confusion part, and it's worse because if it's in a big example, you don't realize that this is happening. Maybe months later, maybe some users will report some strange behavior, and then you'll have to find it. You'll have to deal with this. So, is it a good idea to include namespaces like that? Probably no. Well, not probably. No, it's not a good idea. So yeah, namespace pollution is a real problem because with these clashes, you can get compilation errors or unexpected behavior, which is much worse. And your maintenance will be more difficult. And even the readability suffers, as we said in the beginning, because you don't know just by looking at the code what's going on and why. Yet there is a space for using directives, and that's for literal namespaces. Because it's still true that using directives, they pollute. But for literals, they are useful because otherwise you cannot use literals, so you must use them. But these are carefully designed, and they do enhance the readability. So what are these literal namespaces? So you take, for example, stud chronoliterals, and it will let you write code something like that. Auto duration equals 5s, like 5 seconds. And it's the same as writing stud chrono seconds 5. In this case, the first version is just more readable. So in this case, the using directive is useful. So if not using directives, you can use using declarations. It looks like this: using, and then you put a symbol. And that means that in this case, we only bring in lib print. So we only bring in print, the print function from the lib namespace and nothing else. So if the using declaration is close enough to the usage, then you still know the origin of that symbol. So readability-wise, it's okay. So you can use it with classes, functions, variables, enums, on since C++20, even just with specific enumerators. It's better than the directive, but it can still pollute if you don't use it wisely. So using the declarations are better than using directives, but as we see here, this comparison operator, this greater than operator, is used actually in two ways. Because it doesn't only mean it's better, it also means that the using declaration has a higher priority than using directive. So in this case, we have using namespace A. We also have, that's a using directive. We have a using declaration using B, X, and we want to return X. So we get X from both cases, right? Which one wins?
The B.
The B one, yeah. Yeah. So if you introduce a symbol both using declaration and using directive, the using declaration will have priority. Namespaces can be aliased. You said earlier that it's a problem when you have to write very long namespaces, maybe nested namespaces all the time, and it can also decrease the readability. To remediate that problem, you can shorten long namespace names with aliases. It might improve the readability, might, not necessarily. It depends what aliases you use. And it doesn't pollute directly. That's a clear benefit here. So you see that, again, here I didn't use long namespace names. But we have A, B, C, so a 3 level deep nested namespaces. And we defined an alias for that with the line namespace ABC, A, B, C. And we can still do qualified name lookups like that. And if A is long, B is long, and C is long, then maybe this is good. Maybe. Maybe it depends, on the abbreviation you use. Because if you just use some initials, which is practical, maybe it won't be that readable.
Makes sense.
It has to make sense, yeah, but it's a possibility. So still, if you use them in headers, you increase the risk of redefinitions or shadowing. But well, that's a thing to consider, because here, let's say we have lib HPP, there we have my lib utils, then we define an alias mu for that, but in another file you open up a namespace called mu, which is there. It's not an alias. You don't use an alias just like that. And then okay, what is used? So it doesn't always improve readability, and it can lead to problems. It has to be used wisely, and it's the best to use it to avoid such problems only in CPP files. So if we talk about the impacts on readability and maintainability, well, using directives and using declarations, they pollute namespaces, they pollute your current scope. The using directive might decrease the readability. Still, for literal namespaces, it's a good idea to use them. And well, in general, using declarations are a better option to go with. And also aliases can improve readability. Now let's talk a bit about anonymous namespaces, because not every namespace has a name. Some, well, anonymous namespaces have no name. But what are they? Well, they limit the scope to internal linkage, and they make symbols private to a given translation unit. They help us, as such, avoiding clashes. And you can pretty much have the same results with using static functions in CPP files, but anonymous namespaces are preferred to do that. So basically, when do you want to put something in an anonymous namespace? If it's an implementation detail, if you don't need it anywhere else, then you can put it in an anonymous namespace, and you know that it will not escape from there. Nobody else will be able to use it. So in this case, we have an anonymous namespace where we define some helper function called milliseconds to strings, and you can use it only in the very same translation unit. Now let's go through some best practices. We still have 18 minutes, if I'm not mistaken. So what is covered in coding standards and style guides? That's what we'll try to cover. We first start with the core C++ guidelines. And here are all the rules. You don't have to read it, it's not there for that. But if you get the slides, here are all the links. Okay, let's go through them. So, C5, place helper functions in the same namespace as the class they support. Because as such, well, they are seen as part of the class interface. In any case, where else on earth would you put them, right? But still, it's good to know that that's where you should put them, because it makes the relationship obvious, and it allows benefiting from argument-dependent lookup, something we had a look into earlier. So here is the example, which, if I remember well, I took exactly from the core C++ guidelines webpage. So here we have a namespace chrono, and there we define all type-related, time and date-related services. We also have these classes there, like time and date, but the helper functions are also there, because that's where they should be. And again, as such, relationship is obvious, and you can benefit from ADL. The next one is C100 68, doesn't matter. Define overloaded operators in the namespace of their operands. Because still, it's about ADL. You can benefit from argument-dependent lookup as such, and it increases the readability, and you won't have to deal with inconsistent definitions in different namespaces. So we have a namespace N, where I don't adhere to some style guides. More on that later. We have our struct, and the operator, the plus operator for that, is defined in the very same namespace, which just makes sense, both for readability and ADL purposes. Because again, if it wouldn't be there, then we wouldn't be able to write plus just like that, but we'd have to go through that long syntax that we discussed about. Next one, avoid highly visible unconstrained templates with common names. I think when this was written, we didn't have concepts yet, so now we have more general rules about that, that you just don't want to write unconstrained templates in general, and you do want to constrain them in a readable and meaningful way. But the problem is that such template arguments can match anything, and it can be dangerous with ADL, or at least annoying. And I liked very much this sentence from the guideline itself. It says that the committee cannot agree to exclude unconstrained templates from ADL. Maybe if Herb is still around, we can ask him about that. But so here is an example. We have a struct S in namespace bed, and we have an unconstrained template there. Then we have a template, we have a namespace T0 where we define operator equals for an integer and for that S struct from bed namespace. Probably we are against different guidelines here, but okay, this is the example from core guidelines itself, okay? And then we have our test where we declare an S called bed. We have a vector of integers, and what do we do there? We compare 1 with bed, which goes to T0 operator equals because it's with an integer, right? And with an instance of bed S. And then we have another example where we call size on the vector, and we compare it with the same variable called bed. But in this case, we go to bed namespace because v.size is not an integer; it's size t. So we end up somewhere else where it was not really intended to, right? Yeah, but I think this example shows many bad examples that you shouldn't follow. Next one, use using namespace directives for transition, for foundation libraries, or within a local scope, because using namespace can lead to name clashes, and even STD namespace can clash with the standard library. But it also says that sometimes consistent qualification is verbose and distracting. I still think that it's better to be verbose and seemingly distractive than end up with problems like in this case where we using namespace std. We clearly should not, and then what do? We declare a variable square root sqrt, and then we want to call the sqrt function from namespace std and there is a flash there, so it doesn't work. So you have to be aware of this. Just don't use using namespace std, I think, and you won't run into such problems. Don't write using namespace at global scope in a header file, something we already discussed because it pollutes and it might introduce some order dependencies. Here is the exception that we already discussed. So I go through these just quickly because we didn't learn anything new, but this is also considered in the core guidelines. The next one is to use namespaces to express logical structure. And I just love this one because the core guideline says so much things to to tell about it. That's what you find there. But joke aside, I don't know why. Maybe nobody took the time to write it. Maybe it's just too obvious because this is one of the reasons to use namespaces. But okay, let's use it as a reminder that namespaces are not only for avoiding name clashes, but also to represent the logical and or domain structure of your program. And of course, if you use it well, it will improve the readability and modularity. But well, I'm not sure we'll go into very deep on that later. So don't use unnamed namespaces. Don't use anonymous namespaces in headers. Use them in CPP files because, as said, they give internal linkage. And if you start including headers with anonymous namespaces, it means that each of the CPP files where you include them, they will get the own version of these. They will get the own version of the contents of anonymous namespaces, and it can lead to code bloat. It can lead to violations of the once definition rule, and probably you will face some bugs if you use some static data in there. So in these cases, you can just use normal namespaces. It's better. You can call them maybe detail, and you might have to use inline with them. So yeah, instead of that bad practice where you create in a header, so this is about header files, where you create an anonymous namespace and there you define X, Y, and the foo function. Just use something called namespace detail highlighted right there. Okay. Another rule, use anonymous namespace for all internal non-exported entities. Something we discussed. So if you use something only in a given translation unit, one CPP file, there you put it in an anonymous namespace, and it's very clear that it shouldn't be used anywhere else, and it's just not possible to use it anywhere else. So, and you should prefer the anonymous namespace version over using the static keyword. Sorry, I didn't see you. Sorry. You don't necessarily test them directly. You can test them indirectly because they are, like helper functions, and probably you want to you want to test the functions that are using these helpers. That's how I would do it. So do not add entities to namespace std because of obvious reasons, but it might also lead to undefined behavior. But why would you want to do that, in fact? Do you see any reason to do that? Please.
There's two places you have to.
Yes.
Structured bindings. And I don't remember the other place.
Is it about, I think, hashes?
Oh, yes.
Yeah. But I also saw some examples. Oh, and now I'm freezing. I saw some example where in unit tests, I think someone used it to be able to print with standard cout vector, something like that. And well, we went with different with a different solution because potentially it can be undefined behavior, and we just don't want to risk that. And it's a bad example. So creating like a function, writing a function, my utility within namespace std, it's not allowed. That's undefined behavior. Yes, this is, I think, what we did. Like we defined operator equals for vectors, and potentially UB. So we went with a different solution. But to continue on that and mention what Jason said, sometimes we have to do this. There are some exceptions when you have to open up the standard namespace, because if the declaration depends on at least one user-defined type and the specialization satisfies all the requirements of the original template, then there is an exception and you don't have to deal with undefined behavior. For example, when you have to define a hash function for your type. There's also the Google C++ style guide, which is a widely used style guide. That's why I collected the rules from here. It says that you should use namespaces generously as much as you want, but using directives are forbidden. Use namespace aliases instead if you need them. Using declarations, so when you only introduce one symbol, that's fine, as long as you do them at the right places. And inline namespaces that we haven't really talked about since the beginning, they are forbidden, but allowed for versioning purposes. And they also mention what the core guidelines already said, that you shouldn't use anonymous namespaces in header files. And it also defines how you should, some formatting rules. So you should use snake case with namespace names. The top-level namespaces must be globally unique and recognizable. Nested namespaces should avoid well-known top-level namespaces. So maybe you shouldn't write something like the know my company : std. That's not a good idea. Avoid that at all costs. And you don't have to intend the contents of namespaces, which is quite nice, especially when you have deeply nested namespaces. And use closing comments when you close a namespace, where you just write namespace and the name as a comment, even for anonymous namespaces. So this is wrong formatting because we have some indentation. This is good formatting because we don't have the indentation with extra spaces, and we also have the closing comment. So, but again, use whatever formatting you want, just be consistent. And a few words about my experience with namespaces from a few different companies. So using declarations are usually fine everywhere. At every company, just use them in CPP files, not in headers. Limit the using directives. Don't even use them in CPP files. Namespace aliases are fine, but not in header files. There, you should really avoid them. And don't use very deeply nested namespace structures, because after a point it it doesn't help with readability. It makes things worse. We work with the 3 levels, which can have sometimes a 4th level. The 4th level is for very big systems and detail. So we sometimes use things like imp detail, or maybe API namespace on a leaf level, but that's the API is rare. It's just an option, and you always have to fully qualify things in macros. We'll see an example for that. And an interesting rule that we have is that if you open up a foreign namespace, well, if you open up foreign namespaces a lot, that is often considered a code smell, because it can show a high level of coupling between different systems that you should probably limit. But it's not a rule, it's more like a smell that you should think about it. So I will jump on these quickly, because we already discussed these. I mentioned that, well, you shouldn't go too deeply, because it can lead to different name clashes with unqualified name lookup. We have only a few minutes left, so I want actually to show one example and then jump to the conclusion. So this is the example that I wanted to show. You always have to fully qualify in macros. Why? Well, don't use macros, right? This is the first thing, but maybe sometimes you do for certain things, and you cannot just magically remove all the macros from big existing code bases. Why? Because macros, even if they seem so, they are never part of a namespace, because they are expanded before compilation, and the preprocessor knows nothing about namespaces. Well, it's just about textual replacement, and you might end up with some lookup issues if you don't fully qualify symbols in macros. So let's look at this very dummy example. We define a macro there, ww, with widget n, and then you try to use this macro in another namespace. You might think that the ww is a part of the foo namespace, because it's defined there. Well, it's not. It's not. And as such, well, it doesn't know anything about that widget that is defined in namespace foo. So to avoid such issues, even here, when seemingly widget is declared right before, you should have written foo widget. But you shouldn't just use such macros. So yeah, this I mentioned that each usage of a different namespace is a sign of dependency. Some are needed. You cannot remove some of them. But if you have too many of them, maybe you should think about limiting your dependencies or rethinking your dependencies. So I think that industry best practices are less permissive than the core guidelines, because core guidelines mostly protects the global namespace, and it cares about the STD namespace, not only, but mostly. But most of the coding guidelines protect user-defined namespaces as well, because, well, that's why they were written. So it's high time to conclude, because there must be like 2 minutes left. Key takeaways. Use namespaces to prevent name collisions and to organize your code. avoid namespace pollution, prefer fine-grained and nested namespaces over large monolithic ones, but don't go too deep, and keep naming consistent and meaningful throughout your project. Some practical do's and don'ts. Do use namespaces to group related code. Use using declarations in CPP files, only in CPP files. Aliases are helpful when they are helpful. Use them when they are helpful. And you might use inline namespaces for versioning. But don't use using namespace std in headers or anywhere else. Don't use over-nested, deeply nested namespaces. And don't assume that readers know where a symbol is coming from. And don't just dump everything into a namespace util. You have to think about how you build up your structure. And thank you very much. That was it. I don't think we have a lot of time for questions, but I stay here if you want to. 2 questions.